This is just a brief video to introduce you to methods a little bit, and what we're going to do is just build up a class real quickly, and I'm going to show you some things about how you call methods within a class, and we really will explore this a great deal more once we get into objects and classes and speak of these things in more detail in Chapter 4. But for now, I want you to have enough to at least be able to break problems up a little bit and use methods. And this will also help, I think, in understanding homework number 2 if you're trying to understand how all of these different things I've asked you to implement are going to happen in one program. So I have created a file called methodsexample.java, and that means, of course, that we need to define a class. So I'm going to do that. This will be public class methods example, okay, like so. And we know already that all of our programs need to have a main method. So let's go ahead and create that. And it always has a signature that looks like this. And there it is. So the first thing I want to do is of course, we could do everything that we want to do inside the main method, but when programs start to get a little bit bigger, of course, you can't do everything in the main method. You want to break your problem up a little bit, and so you want to define some other methods and make use of them. And so let me make another one. Let's make a very simple method that will print a greeting for us, and we'll call this about greeting, since that's what we're going to be producing, and maybe we'll receive a message. And what do we want to do in our greeting? Why don't we say something like, we'll do this, system.out.println, and how about we print the string hello, and then maybe how about instead of message, we'll make this a, we'll call it name instead. So I'm going to change this to name up here. How about that? So we get a name, we receive a name into this method, and we're going to print hello, and we're going to add the name, and then let's add an exclamation point at the end. Okay? So what are we trying to do here? Well, we'd like for some other method to be able to delegate, to give some responsibility to this method to be able to print something out for us, and in this case to print a greeting. And so some other method can send a name and say, hey, would you just go ahead and generate a greeting to this name, and then this will of course do it. So let's call that from the main method. The way that we do that delegation is just like this. We could just say greeting, and what shall we do? How about friend? Use the word friend. So what I'm going to do is go over here to this window, and we're going to go ahead and compile that. Okay, and then we'll run Java that compiled class, and you see what's happened. We have the text hello, comma, friend, exclamation point. Well, that looks like this, doesn't it? Hello, comma, concatenated with name, concatenated with the exclamation point. So you see down here in the main, when we used this particular name and we supplied a string literal to it, that matched the signature of a method that we have available to us. That is, it has the same name and it has the same kind of parameter that we were sending there. And so when we do this, then, since it matches that, this is the code that will get executed, the code that's in this method. And whatever was sent to it, in this case, the string literal friend, that will have the name that is given here, whatever that is. You know, I could call it, person, but then down here I would have to use the same name, whatever that is. Okay, so you'll see that will do exactly the same thing. So there's nothing magic in what you call something. You see it does the same thing, right? There's nothing magic in what you call something, but you want to call it something that makes sense for someone who's reading your code so they can understand your intention. So whatever we send here, that will be called by the name person, and wherever I use it in the code, you see that's a variable that's local to this method. Let's go ahead and make another one. Let's do something a little bit different. How about something kind of more math related? What do you say about the area of a circle? We'll do it this way. Static int. No, sorry, let's do it this way. Let's make it a double, because what I want is like the circle area. How about that? And we want to compute the area of a circle. What information do we need? We really just need to know like the radius or diameter of the circle, right? So let's do that. Let's receive the radius, okay? Now, something I want to point out, when we made this first method up here, notice there's one word, and I told you before we weren't going to talk too much about public and static yet, but I will talk about this void right here. You saw it in main as well. This indicates the return type of the method. So when the method is called, it can return a value to whoever calls it, and that way, when the method is called, it will actually be evaluated as something. So it evaluates to a value in the calling method. Now, if the return type is void, void is a special word that means that it doesn't return anything. Okay, so this doesn't evaluate to anything. So we can call it like this, but it ends up evaluating to nothing. It just, you see, has a side effect here that it prints something out. But in the case of computing a circle area, we'd like to be able to send it a radius, and we'd like to be able to get back the area of the circle. And so here, the return type is something. It's not void, it's double, because we're going to return a double, right, a floating point value that is the area of the circle. So what would that look like? We could do it like this. We could say that we'll call it area, okay, equals, how do you calculate it? It's the radius squared times pi, right? So let's just do that. Radius times radius is the quickest way to type radius squared, right? Times pi. And for now, we'll just put pi in here as a constant that we just kind of code in. That's enough of pi, right? That'll do. And the last thing is, if I were to try to compile this right now, it would fail. In fact, I'll show you that. You know, what's the issue? It's good for you to see how to debug things. Look at what it says. Line 15, error, missing return statement, and it points to where the error is. On line 15, let's look at line 15. Here's line 15. There's where it was pointing. It said no return statement. What's the problem? Well, I promised that this method was going to return a double, but I haven't said what double I want to return. Do I want to return radius? Do I want to return 0? Do I want to... No, I really want to return the area, right? So I'll have a return statement that indicates what I wish to return. Now, how do you use this? Well, if I go down to my main here, what I could do is I could say that double A equals about the area of a circle with radius 5. If I could type it, it would be better, right? So something like that. So now you see area with the parameter 5. That I'm sorry, it wasn't area, was it? It was circle area. How about that? That's better. Okay. So now A is equal to circle area with the parameter 5. So I'm sending a value, which will get converted to a double. Okay, it matches, you see, the signature of this. And therefore, when this method call occurs, it will execute that code. The name radius takes the value 5. And so I'm going to get area inside this code being radius times radius. That's 5 times 5 times pi. That would be the area of the circle. And then it's going to return area. Remember, we're returning a double. It's going to return that value that's been calculated. And so this code right here that I have highlighted will evaluate to the value of whatever area was when it was returned. And so what are we expecting? 5 times 5 is 25 times 3, something like 77, 78, 79, somewhere in there. Okay, will be the area of the circle. And you notice that this variable here, a, is set equal to that value. So now let's output it. Okay, system.out. Print line, and what do we want to say? How about we'll say area of a circle of radius 5 is, I need to put that in quotes, don't I? That would be an error too. Okay, is, and now then we just need a, right? And I can add a period at the end just to properly terminate the sentence. Okay, so I'm going to save that. We'll go over here. We'll go ahead and compile it. And then let's run it. Oh, there it is. Yeah, 78.54 basically. Okay, so there it is. There's my period at the end. See, very easy. It's not hard to do that. Let's do something else. I'm going to duplicate that line, but this time, instead of making a separate variable to hold that, I'll just make the call right here. How about the area of a circle of radius 6, for instance, is, what do I need to do? I need to right here, this will be circle area of 6. Now, let's see how that works. Let's compile it. And there it is. 6 times 6 is 36, times pi is about, yeah, that's about right, 113. Okay. So there you go. Now see, here, instead of having a separate variable, naming it, and then using it, I don't even have a named variable. See, I just put the call right there. I'm expecting it to return something that can be concatenated into a string, and Java will convert that double into the symbols that you see here that represent that numeric value and concatenate it to the string. So it's handy like that for us. Okay, let's do another one. Why don't we try something like this? Let's do something with some integers. I've got public static. We'll use integers this time, and oops, I mistyped it. Let's make the cube of another integer, and we'll call it x here. Okay, so we want to return the cube of x. Now I could right here, I could say int x equals, let's say cube equals x times x times x, and then I could say return cube. Okay, that would get it. But we could be more efficient. Rather than actually naming something, just like down there, we don't always have to name a variable. If we're going to return it immediately, we probably don't need to. So let's just do this. I'm going to delete that bottom line. You know we have to return something. We have to return an integer. We're promising to do that. But let's just do this. Let's just say return x times x times x. And that needs to be lowercase. Oops. There we go. Now, you see here we didn't have to name a variable, but it'll do the same thing. That'll function just fine. And how will we make use of our cube method? Well, let's see. Why don't we do this? Why don't we say, for instance, let's do int num equals 4, perhaps, and then we can, I'm just going to copy this code real quick and paste it down here. We'll say the cube of, what do we want? Num, right? The cube of num is what? The cube of num is, and what do we want to concatenate to that? How about just cube of num, like so, okay? And again, I'll just terminate my sentence with a period to be correct. And let's go ahead and run that. And there you go. The cube of 4 is 64. Is that right? 4 times 4 is 16. Times 4 is 64. Yes, that is indeed the cube of 4. See how I've broken up this kind of work. Rather than doing it all in the main, I'm starting to do some things in other methods so that my main doesn't get so long and so difficult to understand and maintain. And this is the way that we break up problems. Of course, these don't do very much, but as we develop more sophisticated programs, we'll really need to break them up. Let's do one more. I think I've got a good idea here. Let's just go ahead. I'll tell you what. Let me get rid of some of these blank lines here, and I'll just duplicate this line, and let's do something else. How about we calculate? I'm just thinking, if we take the cube of a cube, that would be raising something to the 9th power, right? So let's do it with 2, because I can calculate that one. 2 to the 9th power is, and how would we do it? And we'll concatenate that to, how about the cube of the cube of, and in this case, of course, 2, right? Okay, what are we doing? Look at this. We want to raise 2 to the 9th power. I know how to cube something, and if I cube something and then I cube that result, then I've raised the first thing to the 9th. Okay, so you can convince yourself that if I take 2 to the 3rd power and then I raise that to the 3rd power, that's 2 to the 9th. Okay, so I'm going to say 2 to the 9th power is, and then I'm going to calculate. You start from the inside to look at evaluation. So first of all, it calculates the cube of 2. What do you expect it's going to do? Well, here's 2, the x gets the value of 2, and so 2 times 2 times 2 is 2 times 2 is 4, times 2 is 8, so it'll return 8, and now I'm going to do the cube of 8. 8 times 8 is 64, times 8 is, what is that? 512, I think, right? So let's see if that indeed is what we get. We compile it, and yeah, there we go. So now you see the cube of 4 is 64, as before. 2 to the 9th power is 512. So we use the same method, and we actually, for the parameter for this call right here, we actually use the same method again, and it works just beautifully. Okay, I'll make this code available online. I will put this file up there. That's called methodsexample.java. Very briefly, then I want to just take a look back at Approximator and show you a couple of things. This is our homework number 2. And remember, we had these different methods that are in here. I told you, don't change this main and don't make 3 programs. Okay, we're going to use 3 methods, but we're going to keep the program just 1 program. So here it is. We've got our main here, and notice what it's doing here. In these prints, it's calling factorial, and it's sending a value. So factorial of 0, factorial of 5, factorial of 10. You see, those are calling our factorial method up here, which returns a double. It gets an integer, but it returns a double. The reason we use a double here instead of an integer is just so we can make bigger factorials, because integers don't have a very big range, as we discussed in our last class. Okay. Euler's number. Remember, what we were interested in is how many iterations. So for 25 iterations, we send 25. Okay. Same with pi. For 100 iterations, we send 100 as the value to the Leibniz pi. Okay. And if you look up here, you see that's going to be called iterations here. Okay. And also, of course, these have return types. A double has to be returned. Right now, we're returning a double, and remember, we just get the result 0 because that's all that this method returns. Later, you're going to return something more interesting than that. So that's how you want to think about these things. And in a subsequent video, I may show you some more things and try to help a little bit more. But do start working on the assignment. And as I get questions from students, if I think they might be more general, I'll try to do more videos like this. Okay? Have a good weekend.